Hello, and welcome to the practice quiz. So, I uploaded this to Schoology, and I figured I'd just make a quick video solution because it didn't really take that long. So I just thought I'd go through it. Okay, so this is just a solutions guide, and I'll just be kind of giving the quick rundown of how to approach these problems. Not a ton of explanation, though, because I'm not really reteaching the lesson, more as I'm just kind of going through them. So, number one, you're going to have some simplifying problems. This is just, this first page is just operations with our rational expressions. This part A right here is just asking to simplify. So really, this is just a factoring problem. It's just, can you factor these polynomials and then cancel your like terms and all that business, yeah? So I'm going to look at the numerator, and of course, we always keep in mind the first thing we want to do when factoring is look for GCF. Yeah, you're always looking for the greatest common factor. You just are. So I see 6, 27, and 54. I know that 6 goes into 54. However, 6 does not go into 27. I think the GCF there would be a 3. Okay, so I'll be pulling out a 3. But I also have a squared in it, all three terms of this trinomial. So I'm going to actually factor out 3a squared. And then what's left inside is, well, 6 is 2 times 3, so that's 2b squared, plus I factor 3 out from 27, that's 9b, and then minus, let's factor 3 out from 54. If you need to do a quick division of 3 into 54, that's 1, 6, no, 8. 18, so that's minus 18. Okay? And so that's step one for factoring the numerator. Let's go ahead and look at the denominator. And again, GCF, I do see 6 and 216. And by the way, you should recognize that 216 is 6 cubed. That is a perfect cube. And I'm hoping you know your perfect cubes up from 1 through 6. So hopefully you recognize that. I don't think this quiz is going to have a calculator, okay? So I factor out 6a, because I see an a here and here. So that's 6a. And what is left behind is b squared minus 36. All right? Now, I'm not done factoring. That's only the first step, is finding GCF, right? So I'm going to continue to factor. 2b squared plus 9b minus 18, that can actually factor. So here, I'm going to keep the 3a squared. 2b, well, this is where it becomes your approach, okay? You can go through this multiple ways. The way I do it is, well, since 2 is prime, I know that this is 2b plus or minus something times b plus or minus something. And then I just have to think about what gets 18. And we could be trying like 9 and 2 or 6 and 3. I think if they were both positive, 6 and 3 would be good. However, they're not both positive. One's positive and one is negative. That's fine. They're just going to be both negative. So minus, let's see, which one has to be the 2? 2 times 3. No, 2 times 2. Oh, hold on. I'm so sorry. There it is. I think that's it. Yeah. This is called the guess and check method. What Mr. Spake is doing right now is guessing and checking all sorts of stuff in his head. You see 2b times 6 is 12b, and then minus 3b, that is 9b. That's true. And of course, negative 3 times 6 is negative 18. So I factored this using guess and check. But I want to remind you that you have other methods aside from guess and check to do this. The first is to do factor by grouping. And I'm just doing a factoring review here because this is a practice quiz. I want to make sure you're prepared with these things. You do a times c in the top, that's negative 36 because it's 2 times negative 18. And then 9 in the bottom. And then you just have to think what times what is 36 and adds to get 9. What is it? Wait, what is it? What does that? Hold on. Oh, and I don't have my phone, so I don't have a calculator. Oh, and you said, Mr. Spake, you're supposed to do this without a calculator. It's just that I don't want to really think. It's 12 and 9. It's 12 and 3, sorry. 12 minus 3. It's just that, okay? So once we find 12 minus 3 is 9, 12 times negative 3 is negative 36. We could do factor by grouping, say 2b squared plus 12b minus 3b minus 18, and then factor out, grouping here, 2b, and that's b plus 6, and then minus 3, and then this is again b plus 6. Therefore, it's 2b minus 3 times b plus 6. Okay? You could also do the kick it method, right, which is just to do from this step to say b plus 12 over, my leading coefficient was 2, and then b minus 3 over 2, and then, 12 over 2 is 6, so that's b plus 6. B plus 6. But then this doesn't reduce, so I kick it, so it's 2b minus 3. And that's kick it method. Look, I don't care how you do this. I just care that you get it factored and that you get it factored fast, all right? You can't be wasting time, precious quiz time, on a simple factorization like this, all right? But I just took some time here to talk about that to remind you that you do know these methods and you have them available to you. Okay. And then the bottom, well, this is a difference of squares. B squared minus 36 factors as b plus 6, b minus 6. That's just a difference of squares. And so now I'm going to cancel out common factors. If you really want to see how I'm doing this, I'm going to write it like this. 3 times a times 2b minus 3, b plus 6 over 6 is 2 times 3, and then times the a, and then times b plus 6, and then b minus 6. The step I'm writing is not necessary, but I want to make sure it's really clear to you what I'm canceling. B plus 6, those are our common factors. We have 2 a's on top, 1 a on bottom. What we're really doing here is an exponent rule, but just one of those a's cancel, and then these 3's cancel. And so that's all the stuff that's canceling. So it's a times 2b minus 3 on top over 2 times b minus 6 on bottom. Those are fully factored, and you do not need to distribute them further. You can just leave it like that, okay? That's good. That's sufficient. Okay. That problem should not have actually taken that long if you were working it, okay? At least I'm hoping not. Because that factorization with a here, I talked about 3 different methods to do that, okay? So just pick a method you're comfortable with, pick a method you like. Okay, going on to letter B. I got a simple division problem of 2 rationals. This is actually technically a complex fraction because I could write this whole thing over this 3x plus 1, 4y minus 3 over 6 minus 2x, you see, because that's what I'm doing. I'm dividing 2 fractions. But we just wrote this with the division sign to make it easier to read. So we'll just do keep, change, flip, okay? That will handle the division sign. That way we're not too worried about our fraction. So we're going to multiply. And then 6 minus 2x is now on top. And then it's 3x plus 1 and 4y minus 3. By the way, that is not a typo. Okay, it's not 4x minus 3. It's good. Okay, and then now I just want to factor. So I'll factor the numerator. Again, I'm going to just do guess and check here, and this time I'm not going to re-explain the methods. Okay? Here's my 3x, here's my x. I got to make 7, so 7 times 3 is 21. So 3 times 7, that'll get my 21, and I want that to be a negative. This has to be plus 1. Okay? Over, I'm going to factor out a GCF of 10. That's now x minus 3. Like that. Times. Now, be careful with this numerator, 6 minus 2x. This is actually a little tricky, this guy. Yes, you can factor out a 2, but if you factor out a negative 2, it's actually negative 3 plus x, which is actually the same as x minus 3 on bottom. So that's a little tricky there because those are actually common factors that are going to end up canceling. Then I've got my 3x plus 1 and my 4y minus 3. And since I've written this as a multiplication, just notice that x minus 3 and negative 3 plus x, those are the same terms, those cancel. And 3x plus 1 and 3x plus 1 cancel. So, that's it. Ooh, except 10 is actually 5 times 2. So those 2's cancel. Not the negative, however. And so the end result is there's a negative out front. There's nothing else up top, so I got to put a 1 over. And actually, I'm going to write the negative to the side just because. Negative 1 over. The only factor I have left here is 5 times 4y minus 3. Done. And that's it, fully factored. So actually, oh, wait, Mr. Spake. There's an x minus 7 up there, isn't there? Yeah. Whoops, it wasn't a 1. It's an x minus 7. Okay? You can leave it like that. And you can leave that negative off to the side, okay? You don't have to distribute the negative. It's fine. We don't need to write that as negative 7, like negative x plus 7. It's fine. That's good. Okay? If you do distribute it, I will still count it correct. That's okay too. I'm just saying it's not necessary to do so. Okay, moving on to number 2. We want to simplify this rational expression below and be sure to combine like terms. So this is a subtraction of 2 rationals, which means we need a common denominator. So we're going to start by factoring the bottom. Pull out 9. It's x minus 4. Not plus, it's minus 1 over. This factors as x plus 5, x minus 4. So let's identify your LCD. It is 9 times x minus 4 times x plus 5. Okay? And so now I just need to multiply each fraction so that they have the LCD. So I know that the least common denominator is 9 times x minus 4 times x plus 5. But in the numerators, I've got 1 times the missing denominator, right? I've got my 9. I've got my x minus 4. I need x plus 5, so I got to put an x plus 5 up here, top and bottom, right? So that's now doing 1 times x plus 5 minus, and then it's 1 times the other missing denominator, was just 9, actually. Just 9. That was the only missing factor, you see, because it has x plus 5, it has x minus 4, but it doesn't have the 9 on top and bottom. So that's why I got to put that there. Okay, so that's x plus 5 minus 9 over 9 times x minus 4, x plus 5. But when you combine your like terms here, 5 minus 9, that's x minus 4. Ooh. Hey, buddy. Look at that. You actually have common factors on top and bottom. X minus 4 over x minus 4. Those cancels. And so I'm actually left with 1 over 9 times x plus 5. X minus 4 was incidentally, yeah, like so. Okay. Cool. Okay. Now, I'm assuming that should take the majority of your quiz time even though it's only half the points. And this is because I'm hoping that the backside of the quiz will be easy points, okay? Now, here's a warning, guys. This is either an easy 50 points or it's you missed 50 points for no reason, okay? These back three questions are significantly easier than anything that I just gave you here, okay? Now, I'm weighting the points this way because I think it's actually easier to do these, and I want you to have good grades, okay? So these are weighted the same. If you miss this stuff, it's going to hurt you a lot, okay? So make sure you know this stuff. I don't mean to say that as like a threat. I don't want you to miss it. That's why I'm doing this practice quiz with you. I just want you to be really careful. This is meant to help support your grade, but if you don't know it, it's going to hurt, okay? So make sure you're good on your direct and inverse variation. Number 3, suppose x and y vary inversely. Let's write a function that models this inverse relationship when x equals 4 and y equals 1/6. You won't get a calculator with this because I'm keeping the numbers simple, okay? If the numbers were complex, I would give you guys a calculator. So because x and y vary inversely, I have to recall that y equals k times 1 over x. This is the general equation for inverse variation. You have to know this. This isn't going to be on the board. It isn't going to be in your notes, all right? You have to know that that's how to set up the inverse equation. When it says write a function, it just means give this equation but find k, and then finalize the equation by putting k back in so that we have the function written, okay? So it says let's figure out k if y is 1/6 when x equals 4. Notice I just replaced 1/6 for y and 4 for x. Now, to solve for k, I'll multiply by 4 on both sides. So 4 times 1/6, that's 4/6 equals k, which means therefore k equals 2/3 if we reduce that fraction. So our answer is y equals k is 2/3 times 1 over x. And that's our answer. Do you see how fast that was? That's supposed to be an easy 15 points, okay? That's what that's intended to be. It's also an easy 15 points to miss if you have no idea what you're doing. By the way, you can write this also as 2 over 3x, just so you know. That's fine because it's equivalent. It's the same, okay? Next one is joint variation. So I'm going to say, suppose that z varies jointly with x and y. So again, the general equation is z equals k times my two variables, x, y. And I'm doing the exact same thing. Figure out what the function is. So z is going to be 90. Here's k times x is going to be 3 and y is going to be 5. So that's 15. So that's k times 15. I'll divide both sides by 15, which tells me that k equals, how many times does 15 go into 90? Is it 6 times? I believe. 6 times. So the equation is z equals 6 times xy. All right? Done. Done. That's it. Move on. Okay. And now for number 5. Here we go. Write a model for each combined variation. Use any choice of letter to represent each variable. Because I don't care. You don't have to use x and y. You can use whatever letters you like. So letter A here, it says the density of an object, let's call density D, varies directly with its mass, let's call that m, and inversely with its volume, let's call that v. So if it varies directly with its mass, right, that would say d equals k times m. But but then it's inversely with its volume. So that's over volume. That's it. That's it. D equals K times M over V, or Km over V, whatever. That's it. And that's 20 points. And if you can't do that, highest you can get is an 80. All right, so you better be able to write this. Yeah. By the way, density is mass divided by volume, so if you were to actually go out and find K, you probably find that it's 1. Constant variation is 1, I think, because that is the formula for density, by the way. Okay, let's look at another. The intensity of light, intensity, I'm going to call that I, is inversely proportional to the square, that's important, of the distance, D, between the light source and the object. So that would just say that I equals K times, if it was direct, it would be D squared, but it's not direct, it's inverse, so it's 1 over D squared. And then that's it. You see? An easy 20 points. Done. Yeah. Done. Again, you can write this as K over D squared, if you'd like. Okay, and then letter C, the load of a beam is jointly proportional. So I'm going to call load, let's call that L, is jointly proportional to the beam's width, W, and square of its depth, that's D squared. And inversely proportional to its length. Ooh, let's call that lowercase l, maybe. I don't know if I want to use 2 L's. So I'm going to recall, what do we want to call load? Is that just F? Like force? Like a load? I'm just going to call it F, just for fun. F for fun, yeah? So you can use whatever letters you like here, okay? It doesn't matter. So my load will be F, jointly proportional with the beam's width and the square of its depth, yeah? So that's joint proportion is going to be K times W times D squared. And because the square of the depth is what's causing the D squared. And then inversely proportional to the length, well, I'm just going to divide by length L. Done. Okay? So, I mean, if you want to, you don't have to write the bullets between those. You just say KWD squared over L. And that's it. So I hope you see that this backside should not take nearly as long as the front side, okay? By the way, I think on the actual quiz, I don't even think number 5 is an ABC. I think it's just one question. I think it's just like one of them. So I put 3 on here, this practice quiz, so that you could get some practice with it, but on the actual quiz, it's just 1. So that's a one and done, guys. If you didn't know it, yikes, you better know it. It's supposed to be easy points to help you. That way, because I know that this stuff, this simplifying stuff, that's significantly more difficult. And I didn't want the points to hurt you too bad, you know? Like if I weighted the hard stuff at 70 points, then I don't know. I hope you understand my reasoning. Anyway, that's the quiz. That's what you can expect. You got to know all of that. And there you go. I hope it was helpful. And good luck, and I'll see you in class.